Born-Haber cycle. We will be studying about Born-Haber cycle. Okay. This cycle was divided by Born and Haber in 1919. Okay. This cycle was divided by Born and Hyber Born and Hyber in 1919. 1919. Okay. It correlates. It correlates It correlates the lattice energy of a crystal to the other thermochemical data okay. This cycle was devised by Born and Hyber in 1919. It correlates the lattice energy of a crystal to the other the mechanical data or the other the thermochemical data. Okay. The cycle was divided by Born and Hyber in 1919. It correlates the lattice energy of a crystal to the other thermochemical data. Okay. Energy involved in the formation of ionic compound is shown by a cycle process, and the cycle is known as Born-Haber cycle. Okay. The formation of an ionic energetics involved in the formation of an ionic compound is shown by a cyclic process and the cycle is known as Born-Haber cycle. Okay. The cycle was divided by Born and Hyber in 1919. It correlates the lattice energy of a crystal to the other thermochemical data. Energetics involved in the formation of an ionic compound is shown by a cyclic process, and the cycle is known as Born-Haber cycle. Okay. The heat of formation of ionic compound depend upon various energy changes as sublimation energy. Okay. The heat of formation of ionic compounds depend upon various energy various energy changes as sublimation energy. Sublimation energy. Changes as sublimation energy, ionization potential, ionization potential, electron affinity, dissociation energy, and lattice energy. The relation between these energies, can be expressed in the form of a cycle, known as Born-Haber cycle, okay. The heat of formation of any compound depends upon various energy changes as sublimation energy, ionization potential, electron affinity, dissociation energy, and lattice energy. The relation between these energies can be expressed in the form of a cycle known as Born-Haber cycle. The cycle is clearly understood by the formation of sodium chloride. When any compound is formed not from free atom but from solid metal and gaseous molecules, it is essential to consider different energetics which are involved in the formation of any compound, such as sodium in solid state plus half chlorine in gaseous states, that is sodium chloride in solid state plus 98.21 kilocalorie per mole energy. Okay. In the above reaction, the net heat released is minus 98.21 kilocalorie per mole, which is called heat of formation, and delta HFRQ, okay. In the above reaction, the net heat released is minus 98.21 kilocalorie per mole, okay, which is called heat of formation, okay. Delta HFRQ or delta HF heat of formation is minus 98.21 kilocalorie per mole. Okay. This reaction can be represented by different steps by Born-Haber cycle. We can explain this reaction with the help of Born-Hyber cycle. With the help of Born-Hyber cycle. Okay. Okay. Born-Hyber cycle. With the help of Born-Hyber cycle. Then first point. Solid sodium metal is converted to free gaseous sodium metal, and for this sublimation energy is required. Sodium in solid state plus 26.0 kilocalorie per mole energy. It converts sodium in gaseous state. Sodium in gaseous state. Then delta HS. Delta HS is 26.0 kilocalorie per mole, equal to sublimation energy. Sublimation energy. Sublimation energy. Second point. The gaseous chlorine molecules dissociates to atomic form, for which dissociation energy is required. 1/2 chlorine in gaseous state plus 28.9 kilocalorie per mole in chlorine gaseous state in the form of molecules. Okay. Then delta half HD. This is 28.9 kilocalorie per mole. This is the dissociation energy. Okay. And third point. The gaseous sodium metal is converted to gaseous positive ion cation, and the energy equivalent to ionization potential is required. Na in gaseous state from the equation number 1, Na gaseous state plus 118 kilocalorie. That is sodium positive ion in gaseous state. It is converted, the sodium gaseous state is converted, sodium cation ion in gaseous state plus 1 electron is released. Okay. And ionization potential of sodium is 118.0 kilocalorie per mole. Fourth point. The gaseous chlorine atom accepts an electron to form a gaseous anion, and thus energy is released. Then chlorine in gaseous state plus electron accepts, that is also converted in chlorine negative, and that means chlorine anion in gaseous states plus Ea. Electron affinity Ea equal to minus 87.3 kilocalorie. Okay. Kilocalorie. Okay. Then fifth point. Now the gaseous cation sodium positive ion in gaseous state and gaseous anion chlorine negative ion in gaseous state combined to form solid sodium chloride, thus energy is released. Then sodium positive in gaseous state plus chlorine negative in gaseous state, that is sodium chloride. In solid states, plus U. energy, that is U equal to minus 183.81 kilocalorie. Okay. From the conservation of energy of Hess law, the sum of energy in the different steps should be equal to net heat change. Thus, from the according to Hess law, according to Hess, according to Hess law, according to Hess law, delta HF heat of formation equal to delta HS plus half delta HD plus ionization potential plus electron affinity plus U. This is 26 plus 118 plus 28.9 plus minus 87.3 plus minus 183.81. Okay, that is minus 98.21 kilocalorie. Okay, heat of formation is negative for the energy released while it's positive for the absorbed energy. Okay, heat of formation is negative, so for negative energy released when it is positive for the absorbed energy. Okay, heat of formation if delta HF is negative, then energy released and if heat of formation is positive, then energy absorbed. Okay. Then the above process, all the reaction can be shown in the term of cycle reaction, which is called Born-Hyber cycle. Okay. Born-Hyber cycle. Sodium in solid state, that is converted 26.0 kilocalorie and delta HS. Okay, in sodium gaseous state, that is ionization potential 113 kilocalorie. That is sodium positive in gaseous state. Okay, and plus half chlorine gas is 289 kilocalorie 1/2 delta HD. Dissociation energy, that is converted in chlorine gas, and electron affinity, that is minus 87.3 kilocalorie, and this is converted in chlorine negative ion in gaseous state. Okay, that is a delta HF is minus 98.21 kilo calorie, and this is minus 183.81 kilo calorie. That is sodium chloride in solid state. Sodium chloride in solid state. The energy changes. The energy changes is also expressed in the kilojoule by considering kilocalorie 4.18. Okay. Then delta HF equal to delta HS plus half HD plus ionization potential plus electron affinity plus U. That is 108.7 plus 120.9 plus 495.2 plus minus 384.2 plus minus 758.7, that is minus 382.1 kilojoule per mole. Okay. Thank you. Next is utility of Born-Haber cycle.